something unimaginable is unfolding at the heart of our solar system.
NASA just confirmed the interstellar object 3I/Atlas has completely stopped near the Sun, like something's holding it in place.
That's impossible. Comets don't just stop in space. What kind of force could freeze it mid-orbit?
Solar observatories are reporting magnetic distortions around it, as if it's generating its own field.
Reports now indicate 3I Atlas may have intentionally halted its movement, as if it's choosing to remain near the Sun.
A foreign object, an interstellar body named 3I Atlas, is now on a trajectory that defies logic, gravity, and probability. And according to Harvard astrophysicist Avi Loeb, there's a real possibility that this thing could be using the Sun itself to stop. In this video, we're diving deep into what may become one of the most shocking astronomical events in modern history, a discovery that could change not just how we see the cosmos, but whether we're truly alone in it. What began as a faint dot in the night sky has become a global scientific alarm. This is not just another comet. This is a mystery that threatens to rewrite everything we thought we knew about physics. On July 1st, 2025, the Atlas Survey telescope in Chile logged a faint moving object on its deep sky scans. At first, astronomers marked it as another routine entry, one of thousands cataloged each year. But within hours, orbital analysis showed something was very, very wrong. This object wasn't orbiting the Sun. It was escaping it. The velocity, over 55 kilometers per second, was far too fast for anything gravitationally bound to our star. The eccentricity was greater than 1, a telltale signature of something coming from outside the solar system. For the third time in history, astronomers had found an interstellar visitor, but this one wasn't behaving like the others. Unlike Oumuamua or 2I/Borisov, which cut sharply through the solar system at random angles, 3I Atlas was skimming almost perfectly along the ecliptic plane, the invisible flat sheet on which all our planets orbit the Sun. Its tilt, a mere 5 degrees. To astrophysicists, that's not just rare, it's almost impossible. Random comets don't travel this way, said planetary dynamicist Dr. Marina Torres of the ESA. The odds are astronomical, and yet 3I Atlas was right there, threading the cosmic needle as if it were following a deliberate flight path. When Avi Loeb, the renowned Harvard astrophysicist known for the Galileo project, reviewed the Atlas data, he noticed something alarming, not just the orbit, but the timing of its solar approach. According to the latest projections, 3I Atlas will reach its closest point to the Sun, the perihelion, on October 29, 2025. That's just inside Mars' orbit. And here's where it gets disturbing. At that point, the object will be moving at 68 kilometers per second, twice as fast as any spacecraft ever launched by humans. At that speed, if it were to perform even a small retrograde deceleration, the change would be enough to trap it inside the solar system permanently. That's the foundation of what Loeb now calls the sun trap hypothesis. The idea that 3I Atlas might be deliberately using the Sun's gravity to slow down. Loeb compared the maneuver to a slingshot in reverse, using the Sun not to accelerate, but to brake. In his words, if it performs a deceleration burn at perihelion, it could effectively stop relative to the solar system. That's not a natural behavior, that's a choice. The implications, terrifying, because if an object from interstellar space can manipulate solar gravity to enter a stable orbit, then it's not a rock or a comet, it's a machine. Most comets dive toward the Sun from steep, random inclination, sometimes nearly perpendicular to the plane of the planets. 3I Atlas, however, flies parallel, weaving through the orbital lanes of Earth, Venus, and Mars as though following traffic patterns. Orbital simulations from the Minor Planet Center show that fewer than 1 in 100,000 interstellar objects should arrive within 5 degrees of the ecliptic. It's the equivalent of tossing a dart at a spinning globe and hitting a specific street in a specific city. Even stranger, 3I Atlas moves in a retrograde direction, the opposite of the planet's motion, but still perfectly aligned to their plane. For astronomers, that makes no sense. For engineers, it looks like design. NASA's JPL confirmed that its hyperbolic excess velocity, the speed it retains even after escaping solar gravity, is roughly 32 kilometers per second. That means it's not slowing down naturally. If it stops, it will only be because something made it stop. From October 22nd to November 7th, 2025, 3I Atlas will pass directly behind the Sun from Earth's perspective. During this time, every telescope on the ground and in orbit will be blinded. The James Webb Space Telescope, Hubble, even TESS and the Parker Solar Probe all have safety locks that prevent them from pointing anywhere near the Sun. This means there will be a 2-week observation blackout, right when 3I Atlas reaches its most critical point. We will have no eyes on it, no data, no live imagery. If something happens, if it slows down, changes direction, or fragments, humanity will not see it happen. It's the perfect moment for anything, natural or artificial, to occur undetected. When it re-emerges in early November, astronomers will have only one way to know what happened: measure its new trajectory. If it emerges moving slower, even slightly slower, it would confirm Loeb's terrifying prediction that 3I Atlas didn't just pass through our system, it stopped inside it. Based on its brightness, scientists estimated 3I Atlas to weigh about 33 billion tons, one of the heaviest natural visitors ever recorded. But when the object passed near Mars on October 3rd, just 29 million kilometers away, something was missing. It didn't pull on Mars at all. No gravitational tug, no orbital perturbation. NASA's Deep Space Network, ESA's Trace Gas Orbiter, and the Mars Reconnaissance Orbiter all recorded nothing. In 2014, a much smaller comet named Citing Spring passed Mars and caused measurable changes in the planet's orbit. But Atlas, allegedly far heavier, left no trace. The conclusion shocked mission scientists. Either the mass is vastly overestimated, or the object isn't solid at all. Its spin rate, measured from light flicker variations, also doesn't add up. It's rotating too fast for a solid body of its supposed size. If it were made of rock, it would have ripped itself apart. So what is it? A hollow shell, an icy bubble, or something built with intention? By mid-September, astronomers had detected a coma, a vast cloud of gas and dust surrounding 3I Atlas, stretching nearly 180,000 kilometers wide. It was rich in hydrogen cyanide, carbon monoxide, and water vapor, typical of comets, but the ratios were off. The intensity of cyanide was unusually high, the structure oddly symmetrical. To some, it looked too clean, almost controlled. Hydrogen cyanide, when exposed to ultraviolet sunlight, breaks apart rapidly. Yet in 3I Atlas, it remained steady, replenished in a constant rhythm, as though regulated by internal activity. If it were a natural comet, outgassing should fluctuate chaotically. Instead, the emissions followed a precise pattern. Dr. Nao Matsumura of the National Astronomical Observatory of Japan remarked, "It's behaving as though it has a thermostat." As October 29th approaches, the world's major observatories are preparing for the moment of truth. Because if 3I Atlas truly uses the sun to slow down, the evidence will appear immediately after perihelion. The Galileo project, led by Avi Loeb, has created a global tracking network, coordinating telescopes in Chile, Hawaii, and South Africa. They plan to detect even the slightest deviation in outbound velocity. If the object loses around 20 kilometers per second of speed, it could shift from an escape path to a stable solar orbit, becoming the first interstellar object ever captured. But Loeb has warned that natural processes cannot account for such a massive slowdown. Cometary outgassing can alter speed by meters per second, not kilometers. So if a deceleration occurs, something intelligent is behind it. The scientific community is split. Some insist it's just a comet with unique geometry. Others whisper what few dare say aloud: it might not be alone. Avi Loeb's team believes that if 3I Atlas is engineered, it may not survive perihelion as a single structure. Instead, it might release smaller units, probes, sensors, or autonomous fragments, like a seed pod opening under sunlight, scattering its contents into the solar system. In this scenario, scientists would expect to see non-random fragment tracks, pieces moving in straight lines, accelerating or steering rather than drifting. Early models from the Galileo project simulate exactly that. Small, faint objects fanning outward like a dandelion dispersing in slow motion. If detected, that pattern would end centuries of speculation about extraterrestrial technology. But it would also raise a terrifying question: why here? Why now? Sources within NASA and the U.S. Space Force have confirmed the existence of internal contingency memos circulated during the October observation blackout. They outline emergency surveillance protocols in case 3I Atlas changes velocity or emits unknown signals. No official threat assessment has been released publicly, but the very existence of these memos speaks volumes. The documents mention monitoring non-gravitational acceleration signatures and post-perihelion radiometric recovery sweeps. Translation: they're preparing for something they can't explain. Meanwhile, the European Space Agency has quietly rescheduled observation time on several orbital telescopes for mid-November, an unscheduled move rarely made without cause. Even China's CNSA has issued new tracking directives for its Tianwen-1 orbiter, repurposing its Mars mission cameras toward deep space once 3I Atlas clears the sun. Every major agency is watching. Every one of them knows something extraordinary is about to happen. When 3I Atlas emerges from behind the sun in early November, the world will hold its breath, because whatever appears on the other side will answer the question that has haunted scientists for months. If it continues outward unchanged, it was a comet, a beautiful natural wanderer from the stars. But if it slows down, fragments, or begins emitting structured signals, then we are witnessing the first intentional arrival in human history. For now, data from NASA's JPL, the European Space Agency, and the Galileo project confirm the essentials. 3I Atlas will reach perihelion at 1.36 AU on October 29, 2025. Its inclination is a mere 5 degrees from the ecliptic. Its mass estimate remains uncertain due to lack of gravitational influence on Mars.